10.2, we're going to look at solving systems of equations with matrices. And even when you're using a matrix, there's still lots of ways to use a matrix to do it. A matrix is just a different way of representing information. How you still solve it, you have choices. The way we're going to solve is what's called row echelon form, REF. So we're going to turn a matrix into that, combine it with substitution, and that's the method we're going to use. There's another method that eliminates substitution completely, and that's called reduced row echelon form. Not something we're going to do. There's a third method that involves finding the inverse of a matrix. Also not a method we're going to do. The inverse of a matrix is definitely the best way to do it when you start to get into larger variables, because that's when you can use technology to help you more. All right, so let's take a look at this. So we've done substitution, we've done elimination, writing it all out. Now we're going to try to transition over to using a matrix. So a matrix, or you can also call it an array, it's the same idea, is described by its dimensions. Okay, it's always rows and columns. How many rows by how many columns? So if you had something like that as a matrix, and you had numbers in all those spots, that would be a 3 by 2 matrix. 3 rows by 2 columns. Now when we talk about a matrix, this would be the element in row 1, column 1. This would be row 2, column 1. This would be row 3, column 2. It can get a little tricky how you describe where a matrix is, because some people start with 0. Instead of the first row, they call it the 0th row. Then it starts to get a little confusing. So to keep it simple, we'll call the first row, row 1, first column, column 1. Okay, we're not going to use 0. If the number of rows and columns is exactly the same, that's called a square matrix. 2 rows, 2 columns, square matrix. 3 rows, 3 columns, that's also a square matrix. Each thing in the matrix is an element. So you can think of a matrix as, it's just like a storage place for numbers. Right? Each position in the matrix is going to store a number, in our case. So this is a square matrix, 3 by 3. Our book uses the notation for capital letters to describe a matrix. So this is called matrix A. And if you want to describe a particular element in the matrix, this is the notation. You use a lowercase letter corresponding to the name, and then you put a subscript, row, comma, column. So if you want to know what A sub 2, comma 3 is, that means go to matrix A, go to row 2, column 3, and write the number. So row 2, column 3, there you go. So that's the notation for describing a particular element in a matrix. Any questions on that? And a lot of times, you do see a matrix written with these brackets around it. When we start doing a lot of work with matrices, I might leave the brackets off and just write the 9 numbers, or however many numbers there are, without those brackets. But you know today we're working with matrices, so that's fine. So the main advantage, I showed you this yesterday, is you don't write any letters. There will be no letters that we write at all as we're working through using a matrix. Okay, we only need to write down the numbers. When we use a matrix, each column is going to represent a particular variable. So like if you had something like 2, 5, 7, 8 as a matrix, and you'll see that we're going to add another column off to the side like this. Well, if that was your matrix, then that would have come from a problem like this. 2x plus 5y equals 3, and 7x plus 8y equals 4. That's where it would have come from. So these numbers are going to represent your x values. These numbers are going to represent your y values. These numbers represent the constants. And if you're doing a 2-variable system, that's what you'd have. If you're doing a 3-variable system, you would have had x, y, and z. And it's a good idea to make sure your equations are always arranged in alphabetical order so we never confuse the first column with being a different variable. I always want the first column to be x, then y, then z if we have it. This matrix right here on the left-hand side, 2, 5, 7, 8, that's called the coefficient matrix because it's a matrix of all the numbers that were in front of the variables. And then you add on to that, or you augment that matrix with the constants. So onto the coefficient matrix, you're going to augment one more column, and that column will be the constants that were on the right-hand side of the equation. So the coefficient matrix, the part that's on the left of this line, this should always be a square matrix because we're always going to have the same number of equations as we have variables. The number of equations are how many rows are in the matrix, and the number of variables are how many columns are in the matrix. All right, so that's the setup of how we'll set it up. Any questions on anything that I described so far? All right, so the goal is going to be to take what we write down, what I just described, and we have to manipulate it. Okay, we want to change how it looks. But just like when you work with an equation, there's only certain things you can do to it that doesn't mess it up. Well, there are certain things we can do to the matrix that won't mess it up, and it'll still be equivalent to what we started with. Because that's what you always have to make sure you maintain. Whatever you do has to be equivalent to what you started with. And the format that we want to get the matrix in is 1s on the main diagonal and 0s everywhere below it. So in general, it's going to look something like that. When you get 1s on the main diagonal and 0s below it, that's called row echelon form. So turning a matrix into row echelon form is the goal. And the reason why that's helpful is, well, let me show you. I'll just make some numbers up and you can see. Let me do a 3x3 system. So let's say we had 1, 0, 0, 8, 1, 3, 5, 2, that would be a 0 as well. That is row echelon form. 1's on the main diagonal. Main diagonal goes from the upper left to the lower right, and 0s everywhere below. And just make up some numbers over here. Those numbers can be anything you want. Depends what they're given to you as. If you were to write this last row back as an equation, what does that last row say? It says z equals 5. Because you have 0s here and a 1 here, you've basically you've eliminated 2 variables in the equation, and now you can solve for the third one. So we know z is 5. Now, what does this top equation say? Y plus what?
2z
Equals 2. Well, we already know z from the bottom, so now we can plug that in and say y plus 10 equals 2 and solve for y. And then once you have y and z, we can go back to the top row and plug in to that one and get x. So when you do row echelon form, you'll get one of your variables, and then you use substitution to get the second variable, and then substitution again to get the third variable. If you did reduced row echelon form, then you would end up with something like this. 1, 0, 0, 0, 1, 0, 0, 0, 1. And reduced row echelon form is a little bit more work because now you're not only getting zeros below, but you're getting them above, but you don't have to go back and do substitution. All your answers are right there automatically. Z equals 8, y equals 5, x equals 3. We're not doing reduced row echelon form. It's not that much harder once you do regular row echelon form. You just have to go back and do the other half to get the other zeros, but it's just not something we're going to take a look at. All right. So in order to get these ones and zeros in the spots that you want, which is ones on the main diagonal, zeros below, there are 3 things you're allowed to do to your matrix. And these are called elementary row operations, EROs. First thing you are allowed to do is you can take any 2 rows and swap them. Swapping 2 rows in a matrix doesn't affect the answer. It's basically just like if I gave you the equations in a different order. That's all. The other thing you can do is you can multiply a row by a number that's not 0. We did this yesterday with elimination. Sometimes we took an equation and we multiplied through by 5, or we multiplied through by 3. But you can always multiply a row by a number that's not 0. And the third thing, probably the most useful one, is you can add a linear combination of one equation to another. That's like if you had something like 2x plus 3y equals 6, and then I had 6x plus 5y equals 1. And I said to you, I want you to get rid of this 6. I want you to make that a 0. Well, you could if you multiply the top equation by -3 and then add it to the bottom one. I don't know what would happen to the y's and the constants, but I know if I multiplied this top equation by -3 and added it to this one, I would cancel the x out, and it would become a 0. So that's rule 3. Multiplying an equation by a number and then adding it to another one. What I'm going to do is I'm going to use a notation to describe what we're doing at each step rather than writing sentences out. So let's say you wanted to, let's take those two. 2x plus 3y equals 6, and 6x plus 5y equals 1. And let's say I wanted to get a 0 in this spot where the 6 is. The way I would write that, let's call this equation 1. Let's call this equation 2. In a matrix, it'll be the same thing. Row 1, row 2. I would say, take row 1, multiply it by -3. We're going to add it to what's in row 2. And now we have to write where we're going to put the answer. Because in a matrix, you only have a certain number of spots. So when you do a calculation, you have to put the answer somewhere. This is going to represent where we're going to put the answer. So think of that arrow as like you're storing the answer. And then we'll put that with what's currently in row 2. So we're going to do this calculation, and it will replace what's in row 2 right now. So if I were to do that, I would have that as equation 1, because I'm not replacing anything in equation 1. But row 2 is going to become this. So that's what you need to do out. So that would be negative 6x plus 6x, negative 9y plus 5y, negative 18 plus 1. So doing this would result in that. Any question on what I did there?
Why is it a negative 3?
Why is it a negative what?
3.
Because I was trying to get rid of the x.
Oh.
So if I multiply the top by negative 3 and then add it to the bottom, it makes that a 0. And that's the idea of how you get zeros in your system. Okay, you got to look for something to multiply by to cancel out what you want to cancel out. So we're not doing this one again. We're just solving it for the first time. And what do you think the first thing we want to do with this is to get it ready to solve? Put it what? Yeah, put it in a matrix. So 1, negative 2, 1, 2, 3, negative 2, 1, 3, negative 2. We're going to augment that with the constants on the other side. Negative 1, negative 3, negative 2. Now, the first thing you always want to have happen is to get a 1 in the upper left. You always want to get a 1 in the upper left. There's a couple ways you can get a 1 if you don't have one. I'm going to change this number for a second, but I don't want you to write this down. Let's pretend that was a 5. That's not good. One way you could get a 1 in the upper left would be to multiply everything by 1/5. If I had to do that, I would, but that's going to give me fractions everywhere. And I don't really want to start working with fractions in the first step if I don't have to. So rather than multiplying everything by 1/5, does anybody see another way you could get a 1 in the upper left if this was the problem? Yeah?
You can use the third equation. Like for your one range of the equation.
Yeah, you can swap rows 1 and rows 3. And a swap is going to look like this. That's the notation for a swap. Switch rows 1 and 3. Luckily, in this one, we don't have to worry about getting a 1 in the upper left because it's already there. Okay, but that's the first thing you have to do. If you go out of order, you're going to mess yourself up. So get a 1 in the upper left. That's the first thing. The next thing is you're going to deal with the first column. You're going to get zeros in both of these spots. You have to do it in that order. So we're going to get zeros in both of these spots. So let's think how we could get a 0 here. You're always going to use the top equation to get zeros in these two spots. What could you multiply the top equation by so that when you add it to the second row, this number becomes a 0? John? Negative 2. So we're going to do negative 2 times the first equation. We're going to add it to the second. And that's going to replace what's currently in the second row. So we're going to do that. And at the same time, let's do the bottom one. What could you multiply the top row by and then add it to the third row? So we get a 0 here. Yeah?
Negative 1.
Negative 1. So we're going to do negative 1 times the first row. We're going to add it to the third row. And that's going to replace what's currently in the third row. So let's do those two calculations. Just put an arrow there to show now we're doing a step. And these are the two steps we're going to do to get what's here. What row isn't changing in this step? The first, yeah, row 1 is not being replaced with anything. In fact, once you get a 1 in the upper left, it stays the same for the entire problem. So we're going to have 1, -2, 1, -1. Now, this part, I usually just do this arithmetic in my head. -2 times the first row added to the second. So let's go through each one of these calculations. What's -2 times 1?
-2.
Plus 2.
0.
-2 times -2?
4.
Plus 3?
7.
1 times -2?
-4.
Plus another -2? -1 times -2? 2 plus -3. So I multiplied everything by -2 in the first row and added it to the second. It's very easy to make a mistake. I probably will make a mistake, so if you notice anything, let me know. Now let's do this one. -1 times the first row and add it to the third. So what's 1 times -1?
-1.
Plus 1.
0.
0. -2 times -1?
2.
Plus 3? 5. 1 times -1?
-1.
Plus -2? -3. And -1 times -1? Minus 2. -1. Okay. Any questions on that first step? Okay, so now the first column is done. Okay, we have a 1 in the upper left. Okay, that's what we want. The next step is to get a 1 in that spot. So I don't see any row that I can swap with it. And you do not want to swap the top row with anything. You need to leave the top row alone. Because if you swap any rows now, you're going to mess up these zeros. So you can't swap with a row that's above it. Otherwise you'll mess up your column. So I think I only really see one way here to get a 1 in this spot. How are we going to get a 1 in that spot? And what would be the fraction? 1/7. So we're going to have to multiply row 2 times 1/7. And we're going to put that answer in row 2. So rows 1 and 3 are going to stay the same this time. So I'm going to copy those first. 1, -2, 1, -1, 0, 5, -3, -1. And what does row 2 become if I multiply by 1/7?
0, 1, -4/7. And then, oh, sorry, the last one is -3/7. Or sorry, -1/7.
Okay. Not thrilled about having those 7s as denominators. I'm not sure there's anything I can really do about that, so it is what it is. Okay, so that's that step. So we've got a 1 in the upper left. We've got zeros below. Now, essentially what you're looking at is this. You're down to 2 variables and 2 equations. You've got rid of the x variable in 2 equations. Now we're going to get rid of the y variable right here. Right there. You want to turn that number into a 0. So don't use row 1. Because if you start adding row 1 to any of these other rows, you're going to mess up these zeros. You want to use the row that's directly above it to get rid of that 5. So you're going to use row 2. What could you multiply row 2 by? and then add it to row 3, so the 5 turns into a 0. Negative what?
5.
Negative 5. So we're going to do negative 5 times the second row. We're going to add it to the third row, and that's going to replace what's currently in the third row. Okay, so which two rows are not changing this time?
1 and 2.
So 1 and 2. Let's copy those over. 1, negative 2, 1, negative 1. 0, 1, negative 4 sevenths, negative 1 seventh. And now we're going to do negative 5 times row 2 added to row 3. What's negative 5 times 0?
0.
Plus 0.
0.
0. 1 times negative 5
0.
plus 5? 0. So we're almost at the point where we're going to know z, because we don't have an x or a y in this last equation anymore. What about when you multiply this by negative 5?
Negative 49 over 7.
Negative what?
Well, negative 20 over 7. So,
So I'm going to write this down. This is a little tricky to do in my head. So we get 20 over 7 minus 3.
1 7.
So minus 3.
Negative 1 7.
What's the common denominator? 21.
Yeah, so it'd be negative 1 7.
So negative 1 7. And let's multiply this by negative 5. What do we get here? 5 sevenths minus 1. So 5 sevenths. And is that how we would write it? 5 sevenths minus 1. So what is that?
Negative 2 7.
Negative 2 sevenths. Okay. Now let's translate that last row back into an equation. We're done with manipulating the matrix. I mean, well, I guess we could do one more thing. You'd like to have a 1 there, so we can get the last one nice and simple. What could I multiply row 3 by to make that number a 1? Negative 7. And actually that's going to work out nice, because then we're going to get rid of all our fractions. So let's do that. So the last thing we're going to do to the matrix is negative 7 times the third row, and that's going to replace what's in the third row. So what's not changing? 1, negative 2, 1, negative 1, 0, 1, negative 4 sevenths, negative 1 seventh. And what do you get if you multiply this by negative 7? 0. The next one by negative 7? 0. The next one by negative 7? 1. And the last one by negative 7? 2. So now, what does this last equation tell me? Z, 0x plus 0y plus 1z equals 2. Z equals 2. So now we've got z. Now, we're going to use substitution to get the rest. Okay, but we're done changing the matrix. What does this second equation tell me? Y minus 4 sevenths z equals negative 1 seventh. So y minus 4 sevenths times 2 equals negative 1 seventh. So let's solve that. What's 4 sevenths times 2? 8 sevenths. And then I'm going to add, actually this is going to be really good. I'm going to add 8 sevenths to the other side. Negative 1 seventh plus 8 sevenths. So what does that come out to? 1. So now we got y. Now, let's go all the way back to the original equation and get z. X minus 2y plus z.
So
So that was the z, that was the y, and now we're going to do the x. X minus 2 times y plus z equals -1. So we're going to get x minus 2 plus 2 equals -1. That's fine. And we're done. X equals -1. Any questions on the steps there? Unfortunately, not something you want to try to do when you're not really focused on it, because you make one mistake and then everything gets thrown off. So it can be kind of a pain to go back and check. But that's always the general process. Get a 1 in the upper left, get zeros below it, get a 1 in row 2, column 2, get zeros below it, and then get a 1 in row 3, column 3, and you're done. Now, if we kept going with the matrix, you wouldn't have to do any substitution. You'd work backwards now and get a 0 here, well, up here, here, and here. But whether you work back and get the zeros or you use substitution, I think substitution is just easy enough at that point. That's why we do it that way. Any questions? All right, let's try this one. All right, what's the first thing we should do here? Yep, set it up. Okay, so what's row 1 going to be?
1, 0, 1.
1, 0, 1, like that?
Line
4. So that line just separates the other side of the equation. That's why we put it. Okay, my next row? Well, actually, what could my next row be?
160.
You could put this one in. I was thinking of something else you could do.
1125.
1125. Because you can divide everything here by 2. You don't have to, but if you do that right off the bat, at least it, I don't know, makes the numbers a little smaller. So 1125. And what about my third row?
174.
Now, sometimes you try to get clever and you're like, oh, I already have a 0. Can I use that somehow? Well, not really. If you swap it with row 3, you'd say, oh, I already have a 0 in this position. I want to get that eventually. The problem is you're going to end up messing that 0 up if you put it there, because you have to get zeros here first. Getting a 0 somewhere else doesn't necessarily help you right away. So I think it doesn't matter what equation you put in this case, because they all have coefficients of 1. So I would leave it the way it is. Okay. So what do I want to do next?
Get the zeros and the 2 to the bottom left.
Yep, you want to get zeros in these 2 spots. So this is the only step where we do 2 rows at the same time. Other than this step, we only do 1 row at a time. So what could we multiply row 1 by and then add it to row 2 to make this one a 0? -1. So -1 times the first row plus the second, and we're going to replace what's currently in the second. What would I multiply row 1 by and then add it to row 3 to make a 0? -1 again. So -1 times the first, add to the third, and that will replace what's in the third. I'm just going to erase this. Okay, what row is it changing? Top row. So we got 1, 0, 1, 4. Okay. And now let's go through the calculation. What's 1 times -1?
-1.
Plus 1
0.
times -1? plus 1. 1. Times negative 1 plus 2.
1.
Times negative 1 plus 5. 1. Okay. Now do it again. Multiply by negative 1 and add to row 3. Okay, so times negative 1 plus 1 times negative 1 here plus 6 times negative 1 plus 8 7 times negative 1 plus 4 0. Okay, now there is something that happened here that is helpful, and the fact that we ended up with a 1 right there. That's what you want to do next, and it's already done for you. So we have a 1 in row 2, column 2. Okay, what do we want to do next?
Turn the 6 to 0.
You want to turn the 6 into a 0. So what would you well, which row are you going to use to do that? Row 1 or row 2?
2.
Yeah, you don't want to use row 1 because then you're going to start messing up these zeros. So what would you multiply row 2 by? Negative 6, and we're going to add it to what row? Row 3, and that's going to replace what's in row 3. Okay, so there's your next calculation. So this calculation goes with this one. This calculation will go with this one. All right, so what's not changing? 1 and 2. 1, 0, 1, 4. 0, 1, 1, 1. Now, negative 6 times the second added to the third. Okay. Times negative 6 gives me plus this 0. Times negative 6 plus 6 0. Times negative 6 plus 7 1. I mean, this problem really couldn't be working out any better. This is like as good as you can get. Times negative 6 plus 0. So the next step would be to get a 1 in the lower right. We had to do that in the last problem. This time, it happened automatically. So what does this last equation tell me? Z equals negative 6. So that's done. How would this row translate back as an equation?
Y plus negative 6.
Right, y plus z equals 1, if you want to think of it step by step. Now z is negative 6. Y minus 6 equals 1. So there's your second. Y equals 7. Now the top row, x plus z equals 4. We don't have to worry about y in the top row because there was a 0 there. So we don't even need y. So we only need z, which is negative 6. So what is x? 10. And there you go. That was a very nice problem in terms of how it worked out. Okay, any question on that one? Okay. So you can end up with no solution or infinite, but we're not going to deal with no solution or infinite with these types. We may have one with a 2 variable, but not with a 3. With a 3 variable, it will always be 3 numbers. Let's finish up with this one. Why don't you take maybe like 3 or 4 minutes and see if you can solve it. And if you get stuck, let me know. I'll come help you. All right, so the first thing you probably want to do here, you got to get that 1 in the upper left. So you need to swap to make that happen. If you multiply through by 1/4, I would only do that if all these numbers were divisible by 4. Then I would be okay with that. Or Yeah, that's pretty much the only time I would do it. If I have a 1 somewhere else that I can just swap to that position, that's better. So row 2 is 4, -2, 3, 1, and 3, 1, 2, 5. So I'm not even counting that as a step. I'm doing that as like a setup, okay, before I start doing the row. Any questions on that?
Can you swap rows 2 and 3? So you have the one in the middle?
The problem is you can do that, but you still have to get zeros here first. So if you swap them and you put the 1 here, I guarantee we're going to be messing that 1 up right now.
Okay.
Because we're going to be getting zeros here. So what would you multiply the top row by to cancel the 4?
-4.
All right, so -4 times the first row, added to the second, and that will replace what's in the second row. Now, what would you multiply the top row by to cancel the 3? -3. This is why you always want a 1 in the upper left, because then it makes it easy to multiply by a number without a fraction. So -3 times the first row, added to the third, and replace what's in the third row. Okay, so what row is not changing? 1. So 1, 3, -4, -7. Right. 1 times -4 plus 4. 3 times -4 minus 2. -4 times -4. 16 plus 3. Don't like that. Times -4 here gives me plus 1. All right, let's double check that row. I think those numbers are what they are, but so that was 0, -12 minus 2 is -14, 16 plus 3, and 28 plus 1. Okay, now 1 times -3 plus 3.
0.
3 times -3
-9.
plus 1.
-8.
-4 times -3 plus 2. Be wonderful if they're all even. -7 times -3 plus 5. 20.
6.
Okay, now we can multiply that row by 1/2. And honestly, I think working with that row after we multiply it by 1/2 is going to be better than working with that second row. Because if I multiply by -114, I can do that. But I would rather work with a fraction that has a smaller denominator than a denominator of 14. So let's do 2 things. Let's take -1/2 times row 3 and put that in row 3. You know what? I'll just do 1 step at a time. That's going to be more copying, but that's okay. 1, 3, -4, -7, 0, -14, 19, 29, 0, 4, -7, -13. I just wanted this number to also be positive because I'm trying to get it to be a 1 because now I'm going to swap it with row 2. Right? I don't mind working with a denominator of 4 as much as I do a denominator of 14. All right, let me double check. 0, 4, -7, -13. Okay, so that's that step. Okay, next step. I just want to swap rows 2 and 3. So we've got 1, 3, -4, -7. We're going to put 0, 4, -7, -13. times 0, negative 14. 1929. Does anybody have a question why I did that? I just rather work with dividing everything by 4 than dividing by 14. All right, so now, you know what? I probably could have even done that at this step. Instead of multiplying everything by negative 1/2, I could have just done negative 1/8. And that would have saved me having to write it another time. But sometimes that's just not how I think as I'm doing the problem. So I kind of have an extra step, but that's okay. So what would we want to multiply row 2 by now? 1/4, which again, I think I should have built in when I did this step right here, but it is what it is. All right, so 1/4 times row 2, and we're going to replace what's in row 2. So 1, 3, negative 4, negative 7. The bottom row stays the same. And what does the middle row become?
0, 1, negative 7/4, negative 13/4.
7/4, negative 13/4. Okay, not too bad. Only 2 fractions I'm going to have to deal with, and I'm only going to have to deal with them one time. And then once I get a 0 here, I'm pretty much done. All right, what would we multiply row 2 by to make a 0 in this spot? 14. So 14 times the second row, add it to the third row, replace the third row. What stays the same?
First row.
And second row. 1, 3, negative 4, negative 7. 0, 1, negative 7/4, negative 13/4. All right. And what's 14 times 0? Plus 0. 1 times 14? Plus negative 14? 0. Negative 7/4 times 14. Gonna need a calculator for that. 7.
29/4.
Is that what it comes out to?
I think so, yeah.
Yep. 49. You said 49/4. Let me check it again. Negative 7/4 times 14. Negative 7/4 times 14. I'm getting negative 49/2. Oh, and then we have to add. So negative 7/4 times 14, and then we're adding it to 19. It tells me it's a fraction, negative 11/2. And the last one, multiply by 14 and add it to row 3. So negative 13/4 multiplied by 14. And then add that to what was in row 3, which was 29. Plus 29. It's negative 16.5. What's that? Negative 33/2. Okay. And now, rather than get a 1 in this spot, I'm just going to solve this. What does that last row say?
Z is equal, or sorry, 11, negative 11.5 Z is equal to 33/2. Negative.
And what could you do to solve that? Multiply by 2. And then divide by what?
11. Or negative 11.
Negative 11. Yep. So Z is how much? 3? 3. All right. Now, to get Y, we just let's plug right back into the one above it. 0x plus y minus 7/4 z equals negative 13/4. Z was 3. Y minus, what's 7/4 times 3? 21/4. And how are we going to move the 21/4 to the other side? Addition. Negative 13/4. What's negative 13 plus 21?
2.
What is it? 8/4. Which is 2. Y equals 2. Yep. And to get x, we're going to just plug it back into the top one. So x plus 3y minus 4z equals, what was the top one? Negative 7. Or 3 times y. 3 times 2 is, and what's minus 4z?
Negative 12.
Negative 12. 6 minus 12 gives me
Negative 6.
negative 6. So x equals
Negative 1.
negative 1, right?
Yeah.
Perfect. Okay, again, I don't like when the fractions come up, it gets a little annoying, but again, it's the same steps, it's just you have to be careful, use your calculator to help you with that. So this is probably more of like a annoying one, probably one to stay a little bit more away from on a test. This last one we did, this one was just almost too perfect. So probably in between the two is what you'd see on a test. But most of the time I am going to try to have the answers come out to nice numbers, so that way you know if you're getting decimals, you went off track. I'm not going to have crazy decimal answers. Okay? It's going to be integers, positives or negatives. All right. So those are the questions we'll try for tonight. There are some problems that are 2x2 systems with a matrix. We didn't talk a ton about 2x2, but the goal with the 2x2 is that 1's on the main diagonal, 0's below it, but it's a lot easier than a 3x3. And then these numbers could be anything. That's what you want. So we'll take a look at that tomorrow and then finish up what we're going to do this week on Wednesday. Remember, Thursday, you can use that as a review day if you want. If you're not going to be here and you want to take a test, that's fine too.